We do use two units of measure for angles, degrees, and radians. Now, if we're doing triangle trigonometry, it's primarily degrees. When we're talking about rotational, it's radians, and rotational deals with radians often because of the fact that in rotational angles, you're talking about angles that could go beyond 180 degrees. I mean, we're talking about triangles. I mean, the three angles of a triangle should total 180 degrees, so you're not going to have an angle of 180 degrees or more in any triangle. With rotational circumstances, you can certainly have angles more than 180 degrees involved. So, um, that's why we often, when we're talking about rotational instances, we often use radians primarily. And radians are also work well with a lot of calculus concepts more so than degree measurement does. One of the things you always have to make sure that you're aware of is because if you're using calculators at this point still, and you will be, you always have to make sure that if you're working with angles that are in degree measurement, that your calculator is in degree mode, and if you're working with angles that are in radian measurement, that your calculator is in radian mode. Otherwise, that could cause a lot of miscalculations, even though you're doing everything right, you just don't have it in the right mode. So make sure you're always paying attention to the problem, make sure you're paying attention to what mode your calculator's in to make sure that the two are prepared to work with each other, so to speak. So, what's the difference between these two? Radian measure comes from the concept of arc length. It is actually the length of an arc formed by an angle with a radius of rotation of 1 unit. A circle formed from a radius of rotation of 1 unit is often referred to as a unit circle. So, the way I could define a radian, it's basically the length of the arc formed by an angle if that angle is being formed within a unit circle. So, for instance, if I look at a unit circle, the circumference, which is, the formula is 2 pi times the radius, which would be, 2 pi altogether because the radius would be 1. That also represents 360 degrees. So 2 pi would be the arc length for a 360 degree angle on a unit circle. That's why 2 pi radians would be 360 degrees. And if you take half of both sides of that, pi radians would equal 180 degrees. That is the standard conversion factor we often use for radians to degrees. And one of the first things they want you to be able to do is to convert back and forth between the two.